Hello again, and welcome back to Nifty Notions. I'm Jason.
And I'm Andrew.
And today, Andrew, I believe you have another puzzling question for everyone.
I do. Jason, do you know what's holding up the Harbour Bridge in Sydney?
I hope there's something really substantial holding up the Harbour Bridge because I go over it every day.
So just for those who don't know us, we do live in Sydney, Australia, and the Harbour Bridge, I think for most people, is fairly iconic and would know if you saw a photo of the Harbour Bridge that's up on the screen now, you know that we're talking about Sydney in Australia. So the Harbour Bridge, it has a bit of history.
Yeah.
So we've established you don't know what's holding up the Harbour Bridge, I think,
we don't.
because it's quite interesting because it does have quite a large span. But the history is before the Harbour Bridge there were ferries that used to ferry people from the north side of Sydney to the south side of Sydney. The south side of Sydney is the central business district. The north side is called North Sydney. It's 5 kilometres, the mile equivalent's on the screen, and expands westwards about 55 kilometres.
And it's a great place to live.
Apparently. Yeah, I enjoy it. So, in the early 1920s, it was decided that a harbour crossing was needed, a proper permanent harbour crossing, and because the Sydney Harbour is quite a deep harbour and quite a long harbour, and there was a lot of shipping that went westwards of the city. So Sydney is based, the east coast of Sydney is the Pacific Ocean, and then the harbour comes in, which is reputed to be the largest harbour in the world, and expands somewhere around 35 kilometres inland to a place called Parramatta. But there was quite a lot of industry which required shipping to venture deep into the harbour. So putting a harbour bridge across, which was relatively speaking quite near the ocean side of the harbour, so in the early part, for want of a better word, of the estuary or the harbour itself, the bridge needed quite a bit of clearance underneath to allow for shipping to go through. And a lot of ships in those days did have masts, but in these days ships are big and they need clearance, and it still works. So there was a number of designs that were put up. There was a design competition, and these were rendered by the Sydney Morning Herald, and they show what it would look like if the bridges were there today. So the Opera House obviously wasn't there in the 1920s, because that's a 1974 opening.
Doesn't look like Sydney, does it?
No, and then when you look at some of these designs...
Oh yes, looks like the Brooklyn Bridge.
It does, doesn't it? And then this one is like a three-way bridge, quite an interesting bridge. But none of those were successful. The successful bridge was actually modelled on the Hell Gate Bridge in New York. This is a very, very small bridge by comparison to the Sydney Harbour Bridge, but Sydney Harbour Bridge is essentially scaled up from this bridge, and the same bridge designers designed this bridge. So you can see that the thing that the two bridges have in common are the big abutment towers on either side.
Yes.
And quite often...
Huge things.
And a lot of people think, quite incorrectly, that those abutment towers are actually what's holding up the bridge. And for both the Hellgate Bridge and for the Sydney Harbour Bridge, those abutment towers are just decorative, essentially. They don't perform any useful purpose or
So they're a folly, are they?
Yeah, they are, exactly. They're a folly. And they're just there. They're an architectural element to make the bridge look good. It's not needed at all from an engineering perspective to hold that bridge up, because it does absolutely nothing. But the way the bridge is supported is by 4 pins.
Don't like the sound of this.
This is the north side, the base of the north side of the bridge. And you can see there's quite a large triangular steel part thrusting, to use the engineering word, into a big concrete thrust block. And above, at the top of that, you're going to see a round bolted section, and that is where the pin goes through and holds up the rest of the bridge. And there's 4 of these. There's 2 on each side of the harbour, and that is what's holding up the bridge in its entirety. So it allows the bridge to rotate around those pins, which is ever so slight. But when the bridge gets hot, it expands upwards. When it gets cold or when it's cooler, it contracts. I think there's up to about 30 centimetres or 12 inches of movement up and down in the bridge from hot to cold.
Wow. So these 2 primary school children in the photograph...
They would be my children, yes.
They're your children?
Yes.
What happened if they pulled the pin out?
That would be bad. That's an engineering term for bad.
No more bridge.
No more bridge. Of course, that'd be pretty hard to do, but that is basically what's holding it up. But
wow.
also raises the question of how the hell do you build a bridge of this size
Yeah.
when it's only being held up by a few hinged
Yeah.
connections? So you need to support it somehow. And it wasn't practical to support this from the harbour by putting piers into the harbour and then, you know, coming up to support the bridge as it was being erected. Because you can do that, of course, if it was a smaller
Yes.
bridge, but there's traffic that was going through the harbour. So what they did was they actually tied from the top part of the first structural element, which I'll show on the screen. They tied some cables there and they looped them back through the sandstone, in the Sydney sandstone, because Sydney is pretty much all sandstone. It's quite a rigid structure.
Yeah.
So these cables looped back, and you can see the image of those cables
Holding that construction up.
Exactly. So as the arch was being built, you can see the cranes on top. They would bring barges along the harbour underneath where the next construction section was. The cranes that were on top of the arch as it was being built would lift up the next section. They'd be
Amazing.
riveted in place and then they'd move on. And you can see from this photo,
Wow.
you can actually see at the two ends the cables holding those structural elements up.
That's incredible photograph. Almost the two cranes here are kissing.
Almost,
you know?
yeah. And they actually purposely built one side faster than the other in case they came across a structural issue
Right.
or an alignment issue, so then they could adjust the other side to
That
say,
makes
bend
sense.
into place.
Yeah, it's very clever.
And then finally to join them, they had a guide pin, which you can see in this photo here.
Oh, yeah.
It was about 1 metre long and it was tapered. And they had obviously on one side the big pin, which is a big steel element. On the other side, it was basically a target. And they lowered or they released the tension on cables on both sides ever so
Wow.
slowly. And that was the guide that helped to locate the bridge correctly. And as soon as the two sides touched, they riveted the two sides together and the arch was complete.
That's incredible.
Then they dropped the hangers from the top of the arch and started building the roadway from the middle of the arch out to the edges.
Look how small these ferries are below from where they are. That's high up.
That is high up. There's such a high clearance underneath the bridge. For something that was finished in the 1920s, there's quite a lot of forethought. But I think
Yeah.
the clearance issues were all about masts on big ships, rather than just big ships being big ships like they are these days.
Yes.
So
Phenomenal.
that is what's holding up the Hellgate Bridge in New York and the Sydney Harbour Bridge in Sydney, Australia.
So I hope they have different pins if they're not holding up both. But that's incredible.
We don't share the pins.
That somebody would think of using pins as the way of keeping the bridge together.
Well, in structural engineering, and I'm a mechanical engineer, not a structural engineer, but I do understand these sort of things. There are various ways of doing these things. You can cantilever something, which is, where you pin something at two ends and basically you shoot out and it's like a diving board essentially, that's a cantilever. And you could have that coming from two sides and meet in the middle. So you have two cantilevered sections. That's one way of doing it. And then that's allowed to expand up and down. In this kind of construction, the pin connections at two edges or two ends allow expansion and contraction upwards and downwards.
I see.
And then you have other things like the Millau Bridge in the south of France, which has got structural elements coming straight up from the ground with stays holding short sections of span in place. That's a different type again. I mean, you've got all different ways of holding structures up. That's how they did this and how they were able to span about 1 kilometre or just over 1 kilometre across the harbour with a high deck.
That's incredible. Well, thank you, Andrew, for that. That's absolutely fascinating. And that concludes this edition of Nifty Notions. I'm Jason.
And I'm Andrew.
And if you'd like to hit the like button or subscribe, please feel free to do so. Ta-ta for now.
See you later.